very short introduction on what is the webinar, the two parts of the webinar. So you already have seen the agenda, I guess. The first part is focused on the introduction on standards ecosystem, while the second part is focused on the Transmodel itself and the key elements and the implementation aspect. We have 4 speakers for the first part: Fabrizio Arneodo, Christophe Duquens, Nicolas Knowles, and Tuto Tai. And for the second part is Cassia Bourret and Ulf Berging, who are going to present. And very shortly, because we have already lost some time, I will try to give you what is the context of today's webinar. So the context is actually the DATA4PT project. The scope of the project is to support member states in the development and implementation of Transmodel, NeTEx and SIRI, but also of other public transport data, EU data standards. It's a program support action and is funded by CEF project, supervised by DigiMove. It will last 4 years, and we are 11 partners, 9 member states. Among us, DATA4PT is responsible for the technical management, and UITP is the coordinator. And actually, DATA4PT adopts different ways to provide support. The trainings are just one way. It's just one way. Basically, we have also an integrated process for the technical support of the member states. We have the experts team who are now, they are going to present in a few minutes, and experts team provide customized support to technical requests, but also in the framework of the project, we plan to develop tools for validating data, especially when they need to be published in NAP. And we also aim to propose a sustainable business model of support after the end of the project, because we realize that there is a great need, as this is the feedback from the stakeholders involved. So for more information, you can reach our website in this address, and there you can already find some very interesting material that helps the implementation, some guidelines, FAQs, and you can also be able to contact us by submitting your request or your requirement based on the instructions that they are available in the website. So this is from my part. And if Emmanuel is here, I will give the floor to Emmanuel. Emmanuel? No. Okay, very shortly, the agenda of the first part is this one. So we start with the context of standardization of public transport data exchange from Fabrizio Arneodo, one of our experts. Then we will provide you an overview of Transmodel, NeTEx and SIRI, highlighting the key aspects, characteristics, and required skills by Christophe Duquens. Following with the differences between the existing standards, and this will be presented by, again, our expert, Nicolas Knowles. And we will close this first part with a presentation from Tuto Tai from Mobility Data, focusing on the way that Ttfss, GBFS, and NeTEx interoperate. The second part is focusing, as we said, on Transmodel. So we start with the key elements of Transmodel standards, presented by Cassia Bourret. And then at the second, in the second presentation, the focus will be on the implementation and especially on the different case studies that they are now available and will be presented by Ulf Berging. So I don't know now if Manuel is back and wants to say a few words, or otherwise we pass the floor to Fabrizio.
Yes, I'm back.
Okay, welcome back, Emmanuel. Too many technical problems today.
Webinar, but whenever that happens, unfortunately, okay, that's fine. So just few words in introduction. So thank you, Anastasia, to be presenting the agenda. But I just would like to say a few words to introduce this webinar. So this is the first training organized by DATA4PT with the strong support of European Commission.
Emmanuel, it's Sylvia. I'm sorry to interrupt you, but the sound is not clear. So we can hear you now, but we can't understand you, I would say.
Okay, is it better now?
Yes.
Yeah, okay.
Floor is yours.
Okay, last try. I think now it's okay. So just very short introduction for this webinar. So as said previously, this is the first training organized by DATA4PT with support of European Commission and UITP. So my name is Emmanuel de Verdal. I represent Ttfss Association, and I'm also convener of European Standardization Group, where is defined Transmodel. And today I'm quite pleased to moderate this webinar. Just to remind the context of this webinar, so it's in the frame of the deployment of the national access points, which are developed to share mobility data in all member states. And that's key requirements, of course, to support the wide deployment of MAS and all related mobility services. So one of key element of context, and Fabrizio will come back to this part in the introduction, and we'll speak again during the training, is of course the European Delegated Regulation in 2017-1926, which establishes a necessary specification to ensure EU-wide multimodal travel information services. And this includes the use of standard conceptual data reference model, Transmodel. So that's basically the reason why we have initiated this first training as an introduction of Transmodel standard for public transport data exchange. So today, as Anastasia explains, the objective is to share the context of standardization, public transport data exchange, to have an overview of related standards, including SIRI and NeTEx, to link with other data format like Ttfss, and that's why mobility data is also here today as a guest, and also to share implementation examples based on operational use cases. So Anastasia already introduced the experts who will deliver the training today. So I just would like to do it again with Kasia, Fabrizio, Christophe, Ulf, Nix, and Tuto. So thanks to all to deliver this training. So they are all very recognized experts in public transport. They have strong experiences in standardization and also in operational implementation of Transmodel. So now we can formally start the webinar. So the first part is the introduction of standards ecosystem, and Fabrizio will now present you more details about the context and landscape of standardization. So please, Fabrizio, the floor is yours.
Thank you, Manuel. If you, Sylvia, can give me the permission to share, I can start my presentation.
Yes, just need to, yeah, I got you. Okay, you should be able to do it now.
Yeah. Please confirm if you can see my slides.
Yes, it works.
Very good. Okay, so good morning, everybody. First of all, thank you to IT4PT and UITP for asking me to participate as a speaker to this very interesting webinar. I'm Fabrizio Arneudo, and I work since more or less 10 years into the European Committee on Normalization. So today, as already anticipated, I will provide an high-level introduction to the standard context used in the DATA4PT project. Okay. Just a moment, please. As you can see, the context is basically the activities we are bringing in this project are related to the European Directive 2010/40 and the relevant delegated regulations concerning several aspects of the transport, the emergency call, the safety of tracking, and also, of course, about multimodal travel information is the context of the webinar of this morning. And basically, the idea of the delegated regulation is to develop a specification in terms of organization and also technical specification to be followed to ensure the compatibility and in particular the interoperability among different systems deployed in different realities. As far as the delegated regulation 1826 is concerned, it basically concerns the multimodal travel information services, and it provides all the information to be accurate and viable across borders. And so basically it indicates how to develop the national access points, but in particular how to ensure a correct formal communication among member states and so among different national access points, providing and describes roles to be followed in among the various stakeholders, and the information flows, and of course the technical provision to be put in place for this kind of services, but also organizational provision and description is provided in terms of what is mandatory and what is strongly suggested. There are a lot of national standards and European standards that can be seen as a reference for this kind of topics. The delegated regulation, as most of you already very well know, is concerned the suggestion, the indication to use NeTEx and SIRI European standards to exchange static information and real-time information respectively. And in dotted line is strongly suggested to implement and use Open Journey Planning API for the implementation of the so-called distributed journey planner, so to guarantee the correct formal data exchange among journey planners in order to implement the distributed journey planner. There are a timeline requested by European Commission for the sharing of information, and it concerns about First of all, the exchange and the sharing of static information concerning timetables, description of the network, so network topology, and of course the accessibility. Then refine and enhance step by step this kind of information, including bike sharing, so car sharing, the so-called alternative modes, and further detailed information about cycling network. This is the process put in place, and of course the different countries follow different mature situation. Okay, concerning the implementation plan about the dynamic data, basically the plan is to share real-time information about the status of, for example, the situation on the road, about the disruption, but also provide estimated departure and arrival time of the public transport vehicles at specific points, like stop points, for example. And also information, real-time information about the availability of accessible charging stations for electric vehicles or refueling points like CNG. And as already mentioned, also availability of car sharing and or car parking spaces in the reference network. This is the contest of high-level contest of what is required by the delegated acts. And the delegated acts is based on, and it refers on the work done in the technical committee of European standardization. So, and I would share with you at a high level what is the contest in this. As you know, at international level, there is ISO that deal with several standardization aspects, and the technical committee highlighted in the slides are those relevant basically to public transport. And the main reference in Europe is are CEN, the European Committee on Normalization, and CENOLEC. But there is also a strong joint commitment to guarantee the management of overlaps among the different standardization organizations through specific agreement, the Vienna Agreement and the Dresden Agreements, in order, of course, to manage the activities done on the same topics at international and at the European level. As far as the CEN is concerned, the main the technical committee is the 278 that it concern in general the transport and the traffic, the telematic for transport and traffic. And for our interest of this, the work of this morning, the WG3 is the working group of reference for the standardization of all public transport topics. As mentioned before, there are strong relationships and formal relationships starting from international level to the European level, coming through the national levels. And this framework should guarantee the alignment of the standards at the different levels on the same topics. Basically, the work is organized in technical committee, and the different technical committees are then divided in working groups in order to manage more detailed information. And the outputs of this working group could be standard, of course, that is, you know, the technical document with indication of formal rules, guidelines, definition to be used in the development and deployment of the systems, and to avoid problems basically in the interoperability among systems. And the European standards is something very detailed in this perspective. But there are also some gray areas before production of the European standard, the so-called technical specification and the technical reports. Technical specification is a formal document with a strong technical indication, but it's not so mandatory in a formal way. And anyway, it gather anyway all the information needed for the implementation, and is a step before the production of formal European norm. Technical report is an entry point, so is a formal document containing, let me say, information about specific topics, but for dissemination purpose. Consider dissemination in these terms is something very technical, but able to be shared among the community. This picture shows the process for the production of these artifacts. So typically the work can start with a technical report, passing through technical specification, and then arriving to European norm. And on the basis of European norm, European Commission can then provide regulations, and so something that is then mandatory in terms of laws and addressed, inherit at the national level. Okay, coming forward, as mentioned before, the reference for the work is on public transport inside CEN is the working group number 3, that is the steering committee dealing with all the standardization aspects concerning intelligent transportation systems applied to public transport. Is led by Emmanuel de Verdun, and it gathered a lot of member states participation, experts from member states. And it basically is inside and under the TC278, beside other working group dealing with other aspects of standardization. And it basically deal with and divide the work in the several subgroups. Those of our interest have, and in particular, those addressed in the delegated regulation are SG4, 7, and 9, so Transmodel, SIRI, and NeTEx, and also OJP and OPRA concerning other aspects are in a such way indicated and addressed. Very quickly, since the other experts after me will enter more in detail, I can give you an high level of these subgroups work scope. SG4 concern Transmodel, that is European model, reference model for public transport, and this is a European norm provided since several years and frequently updated, and it is divided in the several parts. Each part basically address a specific domain of public transport, like for example transport network, travel timing information, operations, monitoring and control, and so forth. And it is the reference for the other standards like SIRI that deal with is an exchange protocol for dynamics for the real-time information. It stands for Service Interface for Real-Time Information, and it specifies this interface. And similar to Transmodel, it basically is divided in the several parts, addressing here communication infrastructure and facility monitoring and situation exchange. SG8 deal with the distributed journey planner, and as I mentioned quickly before, it is in charge to maintain the Open Journey Planning API. There is an important project, a European project for a preliminary implementation and deployment of this OJP, of this distributed journey planner implementation called Linking Alps, that is currently in progress, involving several European countries. Okay, then there is NeTEx inside SG9, led by Christophe Duquesne, and similarly to SIRI, it deals with static information, not real-time information exchange, and it is divided in the 4 main parts concerning basically the description of the network, the exchange of information about the timetables, so schedule information, and part 3 concerning fare information. Part 4 is the definition, description of the so-called European passenger information profile. That is the reference to be used for the exchange of information among national access points among member states. Then currently there is a part 5 currently in progress for the definition of the exchange data concerning the so-called alternative modes. Then SG10, it deals with is the operator OPRA concerning the definition of which raw data in public transport should be gathered in order to enable calculation of key process indicators, and of course to enable the so-called study and control phase, very useful for public transport operators, but also for authorities in charge to manage contracts. Okay, I'm moving forward to close my presentation. As you can see here, basically the approach is to define a data model using and to be compliant with Transmodel, indicate and identifying the items and the topics to be addressed, then define the way to exchange the data among systems in an interoperability way, and of course, last but not least, to deploy and to develop and to deploy these standards in order to guarantee the exchange of information and the functionality. Basically, the exchange of information is among public transport systems like planning systems, like fare systems, like selling systems, like fleet monitoring systems called AVMs, and of course to provide passenger information. All these domains, all these public transport parts are covered by the standards I very quickly shared with you before, the Transmodel for the definition of the model, but also aspects concerning the selling parts for interoperability, the definition of standards for the equipments installed on board the bus and trams, standards for validators used to check the fare products, but also standards concerning the exchange of, as we saw before, dynamic information and to enable passenger information exchange, and also static information exchange among the planning systems. Okay, so that's all for the introduction of standards to be used in this project, and for the implementation of maps. Thank you for your attention.
Thank you, Fabrizio. Thank you for sharing this overview of standardization context and features. We have a question in the chat from John Peter Ximenez, and the same from Alexandre Cabanis about ticketing related topics. So could you share some words regarding the ticketing scope? You already mentioned right now the fare-related scope from NeTEx. So,
yeah, sure. Okay, concerning the fare part, the standards are quite mature. I would just highlight that in terms of national access point, is not foreseen exchange of information about fares, but there are already standards that address these parts in Transmodel, of course, in NeTEx, as I mentioned, part 3, where basically all the aspects of the fare has been addressed in order to guarantee the exchange of this kind of information among public transport systems. But of course, there are also standards concerning the onboard equipments, in particular for the electronic ticketing systems like validators and like smart cards. All these standards must have to be coherent in order to guarantee the interoperability and the exchange of this information among, let me say, all these different levels of equipments, starting from onboard and moving to the back office application.
thank you, Fabrizio. John Peter or Alexandre, do you want to maybe clarify or extend your question, or is it okay?
Hello, this is John Peter. No, I think it's answered in one of the slides that I saw coming through, so thank you.
Okay, thank you.
Thank you.
I see another question from Laurent Lerena from SNCF about rail transport systems. So do you want to answer this one also, Fabrizio?
Concerning railway, I can see that there is a strong relation with the European Rail Agency, and in this perspective, ERA share use cases with standardization groups, and so several use cases have been for railways have been addressed both in Transmodel, of course, but also in NeTEx standard. And so problems or issues like the coupling of trains, and the management of this kind of vehicles have been taken into account. So these transportation modes have been considered in these standards.
Yeah, thank you. So I can also add that there are some ongoing initiatives of coordination at Sensenelec level to harmonize and synchronize different standards, and this includes strong contributions from UIC, from Shift to Rail in this process. So that's part of the also ongoing process to align and harmonize standards. Last question I see here from Julien Samville and Didier Verlac. Does it mean that IV equipments will all talk SIRI in the near future? Fabrizio, do you have some inputs for this one?
Yes, we should understand what we mean with equipments specifically, but let me say in general, the roadmap is to exchange information among systems for real-time as far as real time is concerned, using SIRI and complying with SIRI for public transport, let me say classic modes, but also for alternative modes. This is something that will be addressed further in this webinar concerning mapping of already existing de facto standards and the European standards. So also, as far as NeTEx is concerned, but also SIRI will be enhanced for alternative modes. So as far as NET is concerned, so coming back to national access point, when the NEP will be available to exchange static information using NeTEx and complying with Transmodel, in the roadmap is foreseen to implement real-time information exchange using SIRI.
Okay, thank you, Fabrizio, and thank you all for the questions. So let's move to the next topic, overview of Transmodel, NeTEx, and SIRI, the key aspects, characteristics, and required skills. So Christophe, the floor is yours.
I will just want to remind you to turn off your cameras when you present, please. And all the rest, turn off your cameras. Christophe, we see, we do not see the presentation.
Can you hear me now?
Yes, now we can hear you, but we see the presenter mode.
Yeah, so I need to change the screen. How can I? Is it better now?
Yes, it's perfect.
Okay, sorry. So hello everybody, I'm Christophe Duquesne. So I'm involved in CN work on the old Transmodel ecosystem for quite a long now, and more specifically, I'm the leader of the NeTEx work, so defining the group who's defining the content of NeTEx. So my part of the presentation is a continuation of what Fabrizio was explaining. It's mainly having an overview of Transmodel, NeTEx, and SIRI, and see what is the scope of each of these standards and how they articulate together on what are the key aspects for them. Okay. So the first thing I would like to share is the fact that it's interesting to define some data categories, and just to be quite precise about what we are talking about. Most often people would say that SIRI is about real time and Transmodel and NeTEx is about scheduled information. But if you look at the details here on the screen, the top green line is all about real-time information, and not everything is in SIRI. So that's also important to be quite accurate about what is included in Transmodel, NeTEx, and SIRI. So if you look at that screen, at the bottom line, the blue line, you have the infrastructure. The infrastructure is basically the roads, the rails, but also the buildings, what we also often call the point of interest, really the infrastructure on which the service, the public transport service is running. And then you have a set of operated infrastructure like the stops, the stop for public transport, where inside you will find the stop itself, but the stairs, the lift, you can have shops and so on. So it's a very accurate and detailed description of the stop. You also have, of course, the public transport network itself, which are the lines, the route, and so on. You may have some freight places for loading and measurements and so on, and the freight dedicated networks that will be, of course, outside of the scope, but that's also in that category. You have parking information, so which can be parking for cars, but also for park and rides. You have car sharing stations, you have bike stations, so that's the second level. The third level is really about the service which is provided. So that's really the PT schedule, so the timetables, the vehicle which are running, but it's going to be also about the PT fare offer. So what kind of fare product you can get and what kind of ride you can get from these products. You will find the similar things for freight, so scheduled freight, freight fares. You will get the parking and toll fares, which are also something important, the taxi fares, the carpooling costs, the car sharing fares and bike sharing fares, so all the fares about public transport modes and what we call new modes or alternative modes. And the top line is the green line is about real time. So real time information can of course be passing times, but that also be incident, occupancy, facility status, and so on. There is a part also which is about public transport control, which is the actions which are performed by the AVMS, what we call the control actions, and you will have such control action also for freights. But in the real-time domain, you will also have usage data like origin and destination. So the way the network has been used or is used at real time. So where people are starting from, where they are doing, why they are doing their journey, and so on. Real-time freight data is going to be also a category. Ticketing data, so that's a complement to the description of the fare offer, but that's really operating the fare offer, so having the validation and the control, so which is also into that real-time category. Road traffic, of course, road traffic control. You will have things like the carpooling offers. This category is a category that can be a bit between real-time and scheduled. You can have a carpooling offer quite long in advance, but you also can have dynamic carpooling, which is really dynamic. So it's always a choice when you do category to put one category real-time or scheduled, but somewhere sometime in the middle. And availability of parking in parking, specifically for car sharing, bike sharing, so knowing where are this, and if there are some available spaces or if there are some available vehicle. So these are the proposed category. If you look at what we have in NeTEx, so here we are highlighting what categories are covered by NeTEx. In the infrastructure, so NeTEx is not describing the infrastructure. It's not describing the roads. It's not describing the rails, but it's describing the point of interest, so which are mainly the points where you can start your journey from or where you can go to in your journey. And you have some carpooling areas and taxi stands also, which are described, but the roads themselves and rail centers are not described in NeTEx. In NeTEx, you will also have all the stop descriptions, from what we call scheduled stop point to stop places to key to boarding positions. So all the details, but also to navigation paths, so walking paths inside the stops and the equipments that you can find. And of course, you will have in NeTEx the network descriptions, so the line and the routes. NeTEx is also giving a quite detailed description of car parkings, so it can be car parkings for car, but there is also specific focus for car sharing stations, park and ride, bike sharing stations, which are covered in the new in detail in the new part 5 of NeTEx. Of course, NeTEx is covering the scheduled information, so timetables for the vehicles information and so on. And NeTEx is also have in its part 3 covering the fare offer description. There's also a bit of the parking toll in the parking fares, which is in NeTEx, and every fares for taxi, carpooling, car sharing, and bike sharing is also available in NeTEx. NeTEx also is going to describe the carpooling offers. So this special category I was talking about, the carpooling offer can be really scheduled, so provided in advance. For example, you're going to have a journey by car from Paris to Nantes in next week, and offering some to carry some additional passengers. But also you can have carpooling, which is real time. That's why it's in the green area. But seen from NeTEx, it's more scheduled information. So that's basically the scope of NeTEx. And if you look at the scope of SIRI, it really complements what you have in NeTEx. So it will provide the real-time information, so the real-time passing time, the incident, the occupancy, the facility status. So is your is an elevator or lift working or not? Is an escalator working or not? Or if it's not working, when it will be repaired? There's a bit of public transport control, and that's the part that's going to be enhanced in the coming months. But there's already some basic information. And we also now have in SIRI all the information about availability of places and availability of vehicle in parkings, specifically for bike sharing, car sharing, and so on. So this is the scope of SIRI, which really complements what you have in NeTEx. One thing you need to keep in mind that this is only the first category. When I was talking about real-time passing time, in fact, if you go in the details, inside this category, you can find a lot of other category, like the estimated passing time, of course, the platform information and so on. But you will have also something which is different, which is the vehicle position, and you will have also the message exchange in the network. So what you will have on displays on stop, for example. You will have the status of equipments. You may have events and incidents and their consequences, so the cause and the consequences of an event, and also occupancy rates in vehicles. So it's important to well define all this category, because when you will go to SIRI, you will have different services for each small subset of such categories. And if you have a wider view of it, so looking at Transmodel, NeTEx and SIRI and OJP and Opera are all based on Transmodel. So Transmodel, I will be back on this later, is really the data model, which is the glue across all these exchange protocols. So as you can see, Transmodel is covering everything covered by NeTEx and SIRI, but also covering more like the ticketing information. So NeTEx, as I said before, NeTEx and SIRI is not about ticketing. There are other standardization groups for ticketing, but the ticketing process in public transport is described in Transmodel. In addition to the categories, you need to also have in mind that. So I see that there's a question. The question on the PT control category. PT control is really what is done in AVMS. So what we call control actions. So having, for example, the change of a driver for some reason, or to stop a vehicle and replace it by another one because there is a specific incident with a vehicle, or to ask a vehicle to slow down because it's going too close to the one which is before him, and so on. So that's all the real-time control of the operations in public transport. It's about regulations. Yeah, that's right. So all these categories of data are provided by different businesses, and that's also important to have this in mind, because that means that all this information is not obviously coming from one single system, but from different systems. So I'm just also giving an overview what kind of business you can find in public transport. The very first of it being the definitions of the needs, which is usually done by the authority. So where people are living, where are they moving from, where they are moving to, what are the mobility needs? It's a bit bizarre, but there's usually not a very well structured digital description of this information. It's more a paper or written PDF maybe, but not very well structured. From this, you're going to do to schedule and create a production plan to fulfill the needs that were analyzed before. So that's from that scheduling systems, you will go to rostering, to scheduling, to plan the vehicle services, and so on. That's really the planning service, and there you will have some specific systems like Hastus, and for example, which is well known for buses specifically, or trams. But that's a very specific system with a view on scheduling and production plans. From this production plan, usually it's sent to an AVMS, so automated vehicle monitoring system, which is going to control and try to make the service as best as possible. So that's really having the GPS locating the vehicles and checking that all is running fine, and taking actions when something has to be done to solve any issue that may occur. So this is operation of the system, and then you have the passenger information, which is taking information from the operation systems, from the VMS, but also from the schedulings of and production plant, gathering all this information and providing journey information through displays, through journey planners, and so on. So on that specific case, on the right, you can see different ways and different kind of systems to provide passenger information. That can be, of course, on web, that can be on board, on display in vehicles, that can be on the ground in stations, or on any place where you will have a display providing passing time plan or real time, or it could be on Apple on apps. Sorry, so Apple or Android usually. So that it's not also one single system collecting information for passenger information, but several of them. From there, you will have indicators and statistics of systems collecting what happened on the network and providing information, so you can optimize the service or optimize the scheduling or whatever. So these are BI analysis and optimization systems. And of course, you will have fare offer definition and ticketing systems. I put it separately. Unfortunately, in these days, a lot of ticketing and fare description systems are not really fully connected to the scheduling or operational system. It's a different track, and that's something which is under solving these days because of the needs of IaaS, where so mobility as a service, where there's a strong need to put all those things together. But up to now, the specifically ticketing is quite independent from the other systems. So to have another view of it, I already gave a short introduction about it. So Transmodel is really the glue that makes all these standards all consistent together. So it's very important. Transmodel is defining the overall model. So it's defining concepts. It's giving a name to each concept. It's giving a definition to each concept, and it defines all the relations across concepts. It tells you what a scheduled stop point is, what a stop place is, what the line is, with very accurate definition. And this definition, so this is really a model. And from this model and this definition, we derivate exchange protocol, which are XML or JSON, REST, or whatever, but protocols. So being NeTEx for scheduled information, SIRI for real-time information, and Opera for operational raw data. So here I show them mainly as XML protocols, but typically SIRI is very often used as a SIRI as a REST JSON protocol these days. So the connections, the fact that these standards are consistent across each other is coming from the fact that they all derivate from Transmodel. Something Tuto will give some words about. If you look at all other specifications, the Ttfss is more or less corresponding to the schedule information of NeTEx, but it's very small subset of NeTEx. It's very useful and very effective to provide information for a journey planning system, for example. But if you go to the operational data, you won't have any operational data in Ttfss, or if you go to the very detailed working paths and equipment of a station, you will not have them in Ttfss, but you will have them in NeTEx. So see Ttfss as a complement, as a very small subpart, but useful of NeTEx. And SIRI kind of corresponds to the Ttfss RT, but in fact, Ttfss RT, it's the same thing. It's corresponding to one service of SIRI, typically the one we call estimated timetable. And so NeTEx and SIRI can be used quite independently, but Ttfss needs really to rely to Ttfss RT, needs to rely to Ttfss. So there's a stronger connection there. So that's just the way I wanted to introduce this here, to start showing how this articulates, but Tuto will give some more details later on. So small examples of what you can do with all these standards with Transmodel. So you can, it provides, that's really the very beginning, it provides a shared vocabulary. So if you have several people discussing, or organizations discussing about public transport, Transmodel provides the shared vocabulary which is needed so people can clearly understand each other. And that's very often an issue. If you take somebody from rail and somebody from bus and put them together, they will at first not understand unless they share the same vocabulary. So it gives a consistent definitions across all the domains. You can use it for definition of a database, and that's a very strong use case. For example, the city of Lyon has built a database based on Transmodel. It's nearly 20 years ago, and it's still fully operational and very strong and very stable. So that's an interesting use case. And it's really going to provide you a way to have consistency across all the systems which are based on Transmodel. So that's really a very strong base. If you go to NeTEx, the typical use case of NeTEx is to feed a journey planner, so it's similar as Ttfss, but also to provide passenger information systems with any information. So that could be for display, I said for journey planner, but also for mapping or whatever passenger information you may need. NeTEx is more and more used for open data, and that's also one of the scope of the regulations. One thing where NeTEx is also often used is you can provide an AVMS with information coming from a scheduling system. So really taking all the details of the running time, the run times, the timing points, and everything which is defined in the schedule system, and providing the AVMS with the needed information to operate the system, the network. Co-operate networks, having several operators operating the same network, also part of the network, but that you need to have exchange of information, late schedule update, and also ticketing pins, meaning that using NeTEx you can describe the fare offer, and that fare offer can be sent to a ticketing system, so it can operate the ticketing. And so for SIRI, you can have runtime, real-time data hubs, a collection of you can use it to create a collection of all the real-time information in an area. So that can be what you have it, for example, for Paris area, but you can have it also at the national level, like Norway is doing, and which is coming more and more. So you aggregate all the real-time information in the real-time data hub. Of course, feed also a journey planner with real-time information, display the real-time information at stop or in any point of interest, provide information to a control center, which may be fully multimodal, and also manage car information. So putting all this information together, having multiple multi-operator connections, so having, for example, multiple operators running the same network, but with different AVMS that needs to share information. Situation management, of course, descriptions and information about their consequences, and so on. So you have a lot of different use case for these standards. So I think that's my last slide, but it's an important one. So as said just before, you've seen that there are a lot of different use cases for NeTEx, SIRI, and Transmodel, and this is one of the reasons we need profiles. The standards are defined by consensus. It's all the requests and all the needs from a set of countries working together at CEN. So that makes standards having a very wide scope and being also some very big documents. But when you go to use it, usually you're going to focus on one specific use case, can be display real-time information on something, or also that could be provide information to a journal planner or exchange information between the schedule information systems, scheduling system and the AVMS. So when you go to this, usually you create a profile which is focusing on your specific need, and then from the standards, you're only going to select the parts that are useful for your specific use case. So you never use the standards fully. You're not going to use everything within which is available in the standards. You're going to use only a subset of it, which is useful for your specific use case. So you have profile. Some are at national level, so the most countries have started defining profiles for scheduled passenger information, for real-time, for accessibility information, for fare exchange, and so on. And we also are having some profiles at European level, like the passenger European profile, so which is as simple as possible. So it's named EPIP, European Simple Passenger Information Profile, and there will be additional profiles at European level for accessibility and for fares, and also about real time. So profiles are important, and usually you will never use the standards fully, only through profile. So that was my last slide. I saw that there were quite a lot of questions. Probably I missed some of them.
Yes, there is a first question from Alexander Klein regarding the NeTEx categories. So maybe you can share some explanation about it.
I don't see the, I have to go back. Next one.
The question is,
yeah. Okay. Yes, so on the categories I was describing, most of them are already fully covered. The only which is not yet fully covered is the one about new mods. In fact, it's covered. We are now finalizing the work. There's an ongoing work about new mods. So when I say new mod, that's vehicle sharing, vehicle pooling, transport network companies, Uber and so on. When I say vehicle sharing or vehicle pooling, I use vehicle to say it's any kind of vehicle. So that can be car, that can be bike, that can be scooter or whatever. And so this work is now nearly over. We are starting reviewing with external reviews for it. So you can consider that all these categories are really fully covered now. Only the official publication of the SIN doc is not yet done for new mods. But if you need some information about it, you should just mail me, and I will be able to send you some information. And yes, about stops, equipments, facilities, and then all this is already fully covered, and we do have already operational systems on these topics. I think there's a question from Fabrice Seta about the relation with Ttfss. So the ERA, European Rail Agency, is really already deeply connected with our work. So we made sure that everything that is available in Ttfss or which can be described using the UIC leaflets is available in NeTEx. Everything about, of course, the timetable, passing times, services, the trains, train numbers, train descriptions, and so on, but also everything about the fare descriptions for rail. And there was quite a strong work. Maybe Nick Knowles will give a few words about it because he was deeply involved in this. But there was quite a strong work with ERA, so with the European Rail Agency, to check that NeTEx is really covering all the fares that could be defined within TAP-GSIR USE leaflets. About the language in which the standards are available, they are basically all written in English. And I would, specifically for Transmodel, I would recommend to keep the English words because as for the vocabulary, that really gives a reference, and translation may sometimes be misleading. Then when standards come to either a national profile or becomes an EN, some countries requires that there is a translation. So that's one. France is one of these countries. So when you go to an EN, so European norm like Transmodel, there is a French description. It was the case for Germany for a long time, but I think it has been changed. So I'm not sure everything is available in German. What usually happens is that when a country is working on a profile, so my last slide, usually that profile is also written in the national language. So that's probably the best to start when you want the national language document to start with the national profiles. And then most reference documents are going to be probably in English. And are there already route planners using NeTEx? Yes, for example, Norway is using OpenTrip Planner, which is an open source journey planner, which is quite widely used in Europe and in US and all over the world. And the latest version of OpenTrip Planner has been enhanced, so it can import and use NeTEx as a feed, and also it has been enhanced because, so as said before, NeTEx is covering more than Ttfss, so also the planning engine has been enhanced to be able to take into account this additional information. Yeah, so that's somebody is providing that information. Yeah, and Nick is complementing for TAP-GSIR.
Thank you.
You're welcome.
For this very useful and detailed presentation. Let's move to the next speaker. So next speaker is Nick Knowles, and Nick will now present some highlights on the differences between standards and one key challenge around the mapping of standards. So please, Nick.
Right, thanks, Emmanuel. Can you hand over the screen and I'll get going.
Okay.
It should be good now.
Okay, great. Can you see that?
Yes.
Good, great. Yep, so I'm Nick Knowles and I'm in the NeTEx and Transmodel working groups and have been working this stuff for quite a few years. I'm going to talk about the differences between standards, so both the ones within the Transmodel ecosystem like NeTEx and SIRI, but also about how we interface with other standards in the wider world, because in a world of open data, we need to recognize that we need to integrate different types of data and that the different standards may be relevant for particular purposes. My sort of by way of introduction, I think it's useful to take a step back and just sort of consider the bigger picture about what we're trying to do here. I mean, essentially, we're trying to build passenger information services that integrate data of lots of different types over quite a large scale, so that passengers have really easy to use information systems. They can do their trip planning and their trip management. But of course, in reality, there are really different processes going on both upstream and downstream. We've got upstream, we've got both the planning processes of the operators, where they're going to create their timetables, create their duty schedules, decide their vehicle allocation, do all the stuff to run the system, and then there are operational systems where they're actually running against a particular plan. So all those also involve data, and it's very much the same data elements that are going to be served up to create the passenger information systems. So, and we also have the actual real-time data, so data that's changing the whole time, which we're necessarily going to need to have APIs to put through, because it is changing all the time. So we've got many different types of data, we've got many different use cases, and we've got many different stakeholders. So to put together the data for an end user system, we're actually taking data from many different operators and trying to make it all fit together. And the consequences of that, first of all, I think that we need different standards for the exchange of the bulk data, which is exchanging fairly on a slower time scale. It is changing, but on a much slower time scale, and it's much more efficient to transmit it as, okay, this is this month's or this is this year's timetable, versus the real-time stuff and the stuff that's changing all the time, for which we need APIs. So that gives us a first fundamental thing with two different types of standards, those for bulk data exchange and those for real-time exchange. And that sort of, gives us the main difference, if you like, between our use of NeTEx as a common bulk standard. And the vision is that we can have one data format that we can use for many different use cases, not just for the passenger information, but also for those upstream services, and that it's designed so it'll fit together with the real-time services, the APIs, the Open Trip Planner APIs. But the challenge, of course, is how do we make this all fit together? And to do that, we have an overriding conceptual model, the Transmodel, that basically gives us a single uniform view of all the concepts that we want to have in our functional domain. And we use that to guide both how we build the bulk data format and how we build the APIs. So that way we can reuse components. So the same stop that I use for my timetable is the same stop I use for my fares, the same stop I use for my real-time stop, for example. So it's all about trying to get reuse and to do stuff in a uniform way, so that we simplify what we have to do. As we have these big complex worlds to deal with, we need to simplify by trying to make everything as uniform as possible. And as Kasia will say quite a lot more in the next presentation, the way we do this is using a conceptual model, so a high-level model, and then systematically engineering that down into a physical model and then into an XML schema. So that of itself also gives us two different types of standards, the conceptual standards and then the actual implementation formats. But then we also systemize so even with a format, there's usually quite a lot you have to say about how you're actually going to use that format. So what use cases, what workflows, who's going to be handling the data, how you're going to, which identifier sets you're going to use. And we do that with something called a profile, which basically specifies which subset of what we want to do. So you can regard a profile as, if you like, a slightly different type of standard, but it's basically pinning down how you use your format. And just to stress the advantages and the importance of this model-driven design thing, it means we've got a high-level model that we can trace through item by item. So an item, a given concept that's in the high-level model appears in the design model, and it appears as an action element with the same name in the implementation. And that allows us to understand the evolution of our model. If we want to make changes, we can do an impact analysis, understand what it's really doing semantically. We're trying to avoid a sort of ad hoc, adding something on and then realizing we should have done it differently, because basically Transmodel took the existing models that were in use in Europe, and then has systemized and harmonized and tried to create reusable components for the future, as Kasia will tell you more about. So what sort of things do we need to think about when we're actually taking a given format and using it? Well, given that we have a rich model, the first thing, of course, is to narrow down the functional scope. So we only need to, NeTEx has many things in it, but in a given implementation, you'll probably only be choosing to use a subset. Because it's modular, it's easier to do that. So you choose your scope. You also will want to choose the granularity. So do you exchange everything, your whole country's data in one big file? Do you break it down by operator or by line or so forth? And those are sort of the two fundamental questions. And then there's a series of further questions you'd probably be thinking about, like sort of versioning. Am I exchanging the whole data set every time, or am I exchanging updates or just deltas? And questions like, which set of identifiers am I going to use in my particular context? To give you sort of a simple visualization of that, I've got sort of two slides here. The first one is just conveying that at any given implementation, like for example, the European timetable profile, is only going to take a subset of the elements. So you've got this rich model that's designed to fit together. You're only typically going to take a subset of the elements in a given implementation, but you're doing that with the comfort that if you want to extend and add to the model in the future, there's a roadmap that allows that to be fitted together, and it can fit together with other use cases that exist. The second slide, I'm showing you the sort of granularity issues. So you might choose to do a sort of traditional thing of having one timetable for one line with all the stops and the information about the operator in it. Or you might have one file document per timetable, and then have another document that has all the stops for the country, and then another document that has all the operators for the country. Or you might have one huge file with everything in it. And which is the right solution, depends on the kind of scale you're dealing with and your use cases and what type of data you're exchanging. You can't be completely prescriptive about it, but because of our architecture and our technology, you can choose the optimum granularity for your particular use case and use NeTEx to do that. The second aspect I wanted to just touch on in my talk was comparing standards and how we achieve a systematic interoperability with other standards. And the two really main cases we want to think about. One is, how do we establish boundaries between standards? Because even with a standard like Transmodel and NeTEx that cover a huge amount of public transport stuff, there are still other areas of standardization like the GIS maps or the road data, or things like parking, or indeed ticketing data systems, there are other standards with their scope. So we want to be able to, one of the advantages of having a conceptual model is we can systematically identify where the boundaries are between our different standards, and establish the entities that are on the borderline, which we need to represent in both standards, so we can integrate data from both data sets usefully. And the other main data case we want to support, of course, is interoperability. I mean, open data is a good thing. It allows us to reuse data from everywhere, and exchange data with everywhere. And having a conceptual model helps us to systematically engineer those kind of interfaces. And it's kind of the way we can go about that is, first of all, if using our model-driven approach, is we can start with a high-level comparison of the concepts and establish where we're using different terminology and a rough mapping, and we'll quite often see that there's what's one concept in one standard is broken down into several in another. Then we can move on to a detailed physical mapping where we actually identify the named elements and the named attributes and make sure everything's in both of that. And then we can actually, with that, we can then actually create an automatic adaptation to convert from one to another when that's going to have to take into account the particular technologies that we're using, what might be XML or CVS or something. And just as an example to sort of illustrate the sort of thing I'm talking about, I'm going to take GTFS. Chu's going to give you tell you much more about GTFS. I'm not going to try and steal her thunder. We've been working with the mobility data team very positively in the past year or so to try and systematically establish a formal mapping that everyone's happy with between the NeTEx and the GTFS standards, and that's all part of a philosophy that if we want to get open data as cheap as possible for everyone in the format that's useful for what they're trying to do, then we should embrace and try and work to make sure that everything fits together. So in terms of the big picture I showed you at the beginning, GTFS is really focused on this delivering to the end system stuff. It's not really interested in the upstream. It doesn't contain all those operational and timing and equipment and accessibility and other sort of rich data that you want from many other use cases. It's focused very specifically on delivering timetables to the end user and some real-time data to go with it. And it's only dealing with a subset of the entities that we're dealing with. And you can sort of visualize the subset bit on this slide. So NeTEx has got lots of stuff in it. GTFS basically is using, and NeTEx is everything in documents. GTFS uses one file per concept, and so is a much smaller set of concepts. It's a slight cheat to say that it's one file per concept, because some of the things like stops, GTFS is actually overloading a record. So GTFS uses the stop record to represent both the whole station and an individual stop and a node within a stop and so forth. I mean, that's probably a legitimate thing to do, but the point is, the advantage of having a conceptual model, you can see that that's what's actually going on. This is the difference between a true representation versus an optimized view for data exchange. Just to give you a couple of slides giving you a very high-level comparison. Of course, we both standards have a governance. We sort of differ really in our methodology in that we're using a model-driven design, whereas GTFS is using bottom-up. We'll tell you some more about that in a minute. And we differ in the ambition of our scope. We are aiming to cover lots of use cases and to have reusable components across those different operational and planning use cases with the passenger information use cases. The quite big differences in the technology, because GTFS is using a sort of old school CVS flat file, which is nice in that you can map it very simply to an XML spreadsheet, but it limits the complexity of the objects you can have, because basically each object is one record, or sometimes you can fold in a couple of other sub-objects into that record, but it's basically that limits how complex you can get with the model. And of course XML comes with a lot of automatic validation, where to achieve the same equivalent in GTFS, you have to have a handwritten validator that stitches everything back together again. So we can sort of kind of visualize that in NeTEx you have one document that you can use frames to organize your different elements into, whereas in GTFS you have one record per file, and you zip it up to make it into a single package. You zip that up into one big package. So how do we get between how do we establish a mapping between the standards? Well, what we can do is we can reverse engineer the GTFS to create a model by looking at where there's a reference between the files. So that's what I've done here. We can color it up with the same colors that we use in NeTEx and Transmodel. In NeTEx and Transmodel, we use a color for each functional area, like yellow is a timetable, green is a stop, which allows you to get a quick Gestalt view of the model, and then we can take each, having done that, we can take each individual element. So here I'm taking an agency element, and I'm mapping, showing that a GTFS agency corresponds to a NeTEx organization or an authority, because in NeTEx we distinguish between two different roles, but they're both types of organizations. This is a thing we'll see very often, that in NeTEx we break a concept down into several pieces, that in one concept. Then we can add in the attributes. So here I've shown the attributes from the GTFS and just shown those attributes where they fit in on the NeTEx model. I've left out all the other NeTEx attributes that are supported. So I think I've lost, I was accidentally hiding slides I didn't mean to hide, so I'm just going to unhide them. So then eventually we wind up with the XML, so we can compare the actual end result. So you have a NeTEx XML that looks like that, you have GTFS that looks like that, and we've got an absolute systematic mapping between those two. And we can have a mapping that we can create an automatic program to map from one to the other. At the end of the day, if you're just talking timetables, if we compare, say, the GTFS model and the NeTEx European profile, they're actually of a similar size and complexity. There's a difference in terminology. The great thing about having a conceptual model is we can be very clear about the concepts and who's calling what. But as I'm showing you here side by side, the two different if you like, the size of the two different models in terms of the number of elements and their relationships, and you can see they're really very similar. But if you want to understand the differences, it's useful to think about the extra layers and the extra concepts that are in NeTEx. So here I'm showing you basically how GTFS represents a trip, so a given journey that a vehicle is making. So the trip consists of a series of times that stops, that's following a given line, and you can have a shape associated with that, and you can be referencing a set of stops. Now you can use a basic use of NeTEx can do exactly the same, where you've got the stops, you've got the trip with the times that stop, you've got the line, and you've got a shape. But you can also in NeTEx, and just a relative visual, don't worry about the detail, I'm just trying to visually show you the difference in richness. The other layers you can have in NeTEx, for example, the timings, so how long does it take to go between each stop, the difference between the, and you can have a different timing pattern from the actual, which can include points that aren't actual stops, so that if you're measuring the route operationally to do schedule adherence, you can do that. So there's a further richness you can have in these extra layers that are in the NeTEx model, and this actually can make things more concise than in the other approach, because if you've got the timing, you don't actually need to have all those times at the individual stops. All you need to know is the start time, and then you've just got one set of timings for how long it normally takes to go between stops. So you can represent many journeys just by the time that the journey starts. So I'm just using this one simple example to kind of give you a flavor of the difference between a minimal approach as in GTFS versus a richer approach in NeTEx. So that, they both have their uses. If the added value that's in NeTEx is really if you want to do the operational and the planning type of stuff. And that's really the core points I wanted to make. So I don't know if there are any questions.
Thank you. Thank you, Nick. So I see there are some exchanges on the chat, question answers. That seems that question have been already addressed. So considering the timing, I suggest to switch to the next presentation, which is fully in continuity with what you introduced around the Ttfss and NeTEx mapping, as we have now the chance to have on board with us today Tito, who represent mobility data, which is a support group of Ttfss. So Tito will now share with us some more detailed information regarding Ttfss, but also GBFS, and mainly how to interoperate with NeTEx. So please, Tito.
It should be working now.
Yes, at least we hear you. Yes, perfect.
Tito, we don't hear you.
So we can hear you anymore.
Is it better now?
Yes, we can hear you now.
I think it was the bandwidth with the camera, so I deactivated the camera. Should be all good now. So I was saying, thank you for the kind introduction. I will, since we're getting very close to the end of the first part, I'll be quick to give us more room for questions. First, before we start, a little bit about me. So I'm the Director of Partnerships Europe and Events at Mobility Data. I'm located in Paris, hence me doing the presentation today. And for any questions, you can ask them in French, English, Vietnamese, if any, or Spanish, and I'll be more than happy to reply. But before we dive into how to interoperate between Ttfss, GBFS, and NeTEx, I'd like to hear from you. How familiar are you with Ttfss? So you can connect to slido.com, enter that MD0412 to take the survey, or use a QR code. I will give ourselves probably 30 seconds to see how familiar you are, so I can adapt the rest of the presentation. Oh, wow, I see this is changing quite a lot, but we have people who are overall quite familiar with Ttfss, with a score closer between 3 and 4. Good. Well, with that said, then I won't be too long. First, I wanted to make sure that my presentation will help you understand better how Ttfss and GBFS were built and how we see the interoperation between them and NeTEx for the upcoming weeks, months, and years. A little bit about Ttfss history. The initial need at the very first start, as Christophe and Nick very rightly said, was about traveler information. You, I, everyone who rides a public transit system want to know the same thing. How do I get from A to B on a public transit line? Where are the next stops? Where are the next passing times? How much will it cost? All that came in 2005 with the birth of GTFS, which was designed to describe traveler-facing information of any public transit system. So it had the advantage of being very simple, being open, and to prevent vendor lock-in. The only disadvantage, as Nick said, was very simple data format, so it cannot represent everything. And in 2005, when it was created, there was no specific governance. Over the course of the year, the GTFS evolved, with the community getting more and more involved to provide changes. It was renamed, since originally created by Google and TreeMet, it was renamed as General Transit Feed Specification. And in 2013, by the time most of us got a smartphone and probably an app with a map on our smartphone, it created the need for a better support from the community. So the GTFS Best Practice Project was created, which led to the incorporation of mobility data. From one standard that was created by GTFS and Google and TreeMet, blossomed an entire ecosystem with mobile apps popping up, and City Mapper, Transit, Move It, you name it, you choose it, you just do the best one that you like. And with them getting bigger, with them growing, what happened is we saw cities creating their own apps and then decided to making them disappear in profits to more global ones, because we all realized that it is easier when you are facing traveler information. Then today, what's the status of GTFS adoption? Well, it has been adopted by over 700 cities or areas, with nearly 3,000 data sets produced by over 1,000 producers, and we're still counting them. For example, I know that on my map, I'm still missing Abidjan, Accra, and so many other cities. The GTFS, since traveler-facing information, is GTFS being consumed by mobile apps. Mainstream trip planner and mobile app providing information to travelers, such as Google Maps, Move It, City Mapper. Well, you have here a list that is not exhaustive nor comprehensive, but it's a couple of the most popular ones. The one in green box are the members of mobility data. So since I said that some of them are members of mobility data, how GTFS is governed, because it's an open standard. Well, when we say open standard, we're saying that anyone in the community can get involved to make it better. And so it's driven by you, the people of the industry, by I, who as a traveler can make some suggestions, for example, if I know enough coding. So it's here to make sure that GTFS adapts and grows to meet the changing needs of producers and consumers. So it's an open license. It drives on public conversation, and everybody, anybody can propose a change, vote, or has veto power. So GTFS, since it's driven by the community, is growing at the industry pace. It has no theoretical feature in the sense that a change, any change suggested, must be produced and consumed by the industry before any call for a vote. So the all future proposal for change can be submitted in the GitHub repository, but they will say future proposals until anyone uses them to translate the service information, and that translated service is consumed in production by a mobility app. So I'll go briefly over what GTFS is today as per the latest industry consensus, what it represents, though Nick has already tapped into it, so I will be very brief. GTFS schedule, which is the most widely used and can somehow, as Christophe and Nick said, can be a little bit compared with NeTEx, has 6 minimal functionality, which are all required to describe a service. It needs to include stops, routes, the agency details, calendar, when is the next trip available, trips, and stop times. In addition to that, there are 10 extensions which are adopted, meaning that they were produced and consumed by the industry, which are optional. And again, they are only additional information. You don't have to express them. And they all refer to a GTFS schedule. So the 10 adopted extensions as of today are the shapes of the route, continuous stop, meaning that sometimes in a service, you can hail a bus if it's going through the street without a formal stop, transfers, pathways, which is mainly for accessibility, vehicles, station entrance, pathway routing. For example, if you have, if you're moving and you don't want to take stairs, it will take you through a route without staircase, boarding areas, translations, especially for countries where you have either a lot of tourists or you have numerous official languages, and stop text to speech that will support the machine, the system, to read the name of the stop without reading the letters as it is written. Then we also have in GTFS real-time information that can be compared slightly to SIRI, as Christophe said, but not fully. And they're here for four main use cases of real-time information, which are the estimated time of arrival, the localizations of vehicles, service disruption, and service alerts. And as Nick said, as of today, we're working with Fabrizio, Christophe, Nick, the team, to make sure that the two standards are fully interoperable. We are working on a canonical mapping, and as I said in the chat, it's a work in progress. We will make sure that once it's complete, it gets approved by CEM and all the authors, so we can support the community to improve conversion tools to reduce the effort of producing and consuming data for all. This is a response to the industry needs with software providers such as En Route, who are using both, who are supporting the mapping between both, and Tour, which is in the Nordics, and use both NeTEx and GTFS, or even like in the France Mobilité, who use NeTEx to describe all the operational internal services, and will also produce a data set in GTFS for traveler-facing information. Now, quickly about GBFS, since NeTEx is moving on to new modes of mobility. GBFS was created a bit similarly as for the public transit options. The minute we saw shared mobility options come to life, all users, you, I, had the same preoccupation. Where can I find stations? What kind of vehicle types is available? Is there any vehicle available? What are the usage restrictions? How much will it cost to me to do that? In response to this, in 2014, the GBFS, which stands for General Bike Share Fleet Specification, was born to describe, again, traveler-facing information of a shared mobility system. The advantages were that it's a very simple data format, open data most of the time, and it prevents vendor lock-in because it's open. The disadvantages, again, it's very simple. You cannot represent everything. In 2014, Mitch Vaz, who is part of Mobility Data team member, created a GBFS inspired by GTFS, with the same process for governance, with the same openness to the industry needs, and with the same idea behind that anything that is changed or proposed as a change to the specification must be produced and consumed by the industry. In 2016, it started spreading a little bit around the world, up to the point that to include all the different new use cases, we rapidly went to version 2.2 to adapt to all the new services. So what does the v2.2 represent today? Stations, more often than not docking stations, the station status, the vehicle status. It also has deep links to help you book and pay and plan directly into the native operator mobile app, a contact email, so you can contact the data producer to whenever there is a break in the data set feed or something that you don't understand, versioning, vehicle types, geofencing, meaning the limits of an area in which you can use the shared mobility solution, virtual station, and you've seen them more and more in Europe, in cities. Now we have on the pavement, on the sidewalk, delimited areas where you can park the shared mobility vehicle without it being an actual station, and pricing. So now that I've briefly introduced again over Ttfss and GBFS, how can we compare them? As Nick said, they were built with two very different approaches. So it makes them very hard to compare after all. The NeTEx was thought based on a very strong model, that is Transmodel, that which authors have thought about all the different use cases and options in the mobility world, whereas Ttfss and GBFS comes from the industry. So every time there was a need from the industry, it was implemented, it was created. So it's so different in approach that it makes it very hard to compare after all. So ultimately, if there is one message I want to share with you across the room today, is that data formats are means and not ends. What we want and what we are all working for is to make sure that passengers, travelers are given high quality information in a standardized way. And so us at Mobility Data, we don't push for either Ttfss or NeTEx. I know sometimes there is a confusion about that. We see two possible success paths for the upcoming 10 years. Either NeTEx has replaced Ttfss and everybody has more precise traveler information, or Ttfss and NeTEx still live together with different use cases. We are all building on top of the same ecosystem and we are all facing the same challenges. I mentioned the ecosystem that Ttfss and GBFS has built, and on top of which NeTEx will be building. What is this ecosystem? It's foremost an open source ecosystem. It is OpenTripPlanner that was mentioned in the chat, or some others that you can see here. It's also an ecosystem based on what we believe is needed to make it blossom. So we need to make sure that this ecosystem adopts a standard or the other. That is why we are putting also some training in partnership with DATA4PT. We did some in French, Spanish, English, upcoming are German, Italian, Portuguese, Arabic, Japanese. All of our trainings have 25% of NeTEx presented, because it is important to make sure that we are all going in the same direction. We have resource center, but we also put tools and services together to make sure that people have access to canonical validator to assess if the data sets they produce are good or not. A grading scheme, because knowing that your data set is good or not is not enough. You also need to understand what can be improved. Is it the way you present the line? Is it the way you represent the route? Is it the way you describe the schedule? And on top of that, what is very important is discoverability. If the traveler, if the user doesn't know what service is available, if the trip planner apps can't consume the data, then all this would have been for nothing. So we have a database that is hosting multiple formats. will soon include NeTEx, a database that is acting a little bit like a world access point, a dataset catalog for GBFS, which is kind of the same. And also we're working on archives to make sure that we capture the past, because we have real-time information, either via SIRI or GBFS or Ttfss real-time. We want to make sure there is a way to harvest the data that was produced before, so some analysis can be conducted. And to make sure that we keep on improving Ttfss and GBFS to the needs of the industry, we rely on all the different entities who are part of the industry, software vendors, authorities, operators, public entities, other nonprofit organizations, or mobility apps. The main idea is here to be taking all the feedback from the industry. So now that we've taken the feedback from the industry, how do we move forward together? Well, first, as I said, what we want is to make sure that travelers' information is better. So we need to support each other in improving the ecosystem of traveler information, making sure that we all share the same culture of data, the same culture of open data, data freshness. What does it mean? How do we address this? How can we make sure that the modeling is uniformed between producers so the data can be understood by all? And foremost, we want to make sure that the community knows that we should talk to each other, producers and consumers. We need to understand how the data was produced and how it will be consumed to make sure that mobility apps and mobility altogether gets better. So all in all, 15 years ago, an ecosystem was created around travelers' information. That ecosystem is still, well, 15 years. It's still a teenager, right? Still has a lot to learn. So the best would be for NeTEx to be building on top of that ecosystem and make sure that it provides the real good travelers facing information for the industry as a next generation. And ultimately, if there is one thing I want you all to take from this webinar today is we share the same number of stakeholders. They all have the same needs. They all have the same challenges. So we need to work together to avoid duplication of work, to make sure that resources are spent wisely. So all in all, let's make sure that we keep on having this open conversation and we can all improve the way that travelers are given other options than driving their own car to get from A to B. So I think it's now time for questions. I see some in the chat. Okay, Eve, you were saying that you don't think that the EN standard is a top-down process. I beg to differ in the sense that what CN did with Transmodel, with NeTEx, with SIRI is very strong in the sense that it's solid. It's based on a very solid model and representation of mobility data. But it doesn't necessarily come from a lot of what are easy to implement, what is the real day-to-day needs from some operators who are smaller, who might not have a big team to dive into understanding a NeTEx profile. So when I say that Ttfss, GBFS was created bottom up, they were created because there was a need in the industry, and they are very simple because they took the questions and the needs from the industry and they built on top of it. So that is why I'm referring is that like a difference of top down and bottom up. But I do also believe that people will, well, Christophe, Nick, Fabrizio will also agree with that because we have talked about that quite a while. I hope I replied to your question, Eve.
Yes, thank you, Tuto, for this very complete overview of GTFS and GBFS. And yeah, of course, working together between Transmodel ecosystem and GTFS ecosystem will secure interoperability of related standards. And basically, the ongoing mapping work between NeTEx and GTFS is one concrete example, which is happening now. It's part of the discussion I saw on the chat. Also, the complementarity between the PTA, PTO requirements on public transport operation, which is mainly the driver for NeTEx development, and industry requirements you highlighted in your presentation on GTFS part is very good match to achieve this objective of interoperability. And at the end, as Christophe mentioned in the chat, the standards themselves are just tools to offer a seamless mobility experience. So what's really important is to have this complementarity and shared community to secure the interoperability. So thanks again for this presentation, which close part 1 of this training. And yes, considering the timing, I would suggest to switch directly to the part 2 of the webinar. So the second part, which will be now focused on key elements and implementations use case around Transmodel. So we'll have a first presentation from Kasia Bourré on key elements of Transmodel standards, and then a presentation from Ulf Gersing regarding some case studies. So let's start with you, Kasia. Thank you.
Hello. I hope you can see my screen.
We can hear you and we can see your screen.
Okay. So my name is Kasia Bourré. Several people know me because I've been working for a long time within the standardization world. I've been also at the start of Transmodel many years ago. You will hear the history. I am in the group, in the standardization group. I am leading a subgroup concerning public transport data models, and I am part of the other subgroups, NeTEx, SIRI, Opera, and OJP. So I'm based in France and working now in the team of DATA4PT experts. I don't want to bore you with a lot of repetitions, but you will see from another with another voice some features about Transmodel expressed here. So what I want to stress are once more the Transmodel main features. First of all, to draw your attention to the fact that Transmodel is called reference data model. A reference, and it has a certain meaning. Someone already, I think it was Nick, told you that it's absolutely not, even if it's a European standard, it's not mandatory to use the whole data model. And also you can have some deviations. As users, you may need some additions, extensions. But a reference is here to express also these differences. So this is the meaning of reference. It's published under the number, as every standard, under the number EN 12896. And as also already mentioned in the first part, it is mainly a common language. It started as a common language and describes data structures to describe the meanings of different data elements, concepts of the public transport domain. For instance, if you think about the concept of a route or a concept of itinerary, it's not always clear what it means. And Transmodel, one important feature is that we don't use the word itinerary, but we use the concept of a route, which is a schematic representation of a path of a vehicle. And it will be used in different, it's independent of the application where it's used, or the user, or the country. By the way, someone asked why Transmodel it's advised to use the English version of Transmodel, and I can say that, well, it comprises around 1,600 different terms and concepts, and there is a translation of the main concepts, a glossary that you can even download from the website, with translations of the definitions, as exactly the definitions and the semantics are the most important thing in our work. One important feature is the multi-modality, as it describes aspects covered by the conventional public transport, so by the schedules operation as regards buses, coaches, but also rail, and includes the flexible transport. And in the last 2 years, we have extended it to the alternative modes, so vehicle sharing, pooling, rental, and taxis. These features will induce a certain or help into interoperability between the information processing systems and the communication between operators, authorities, and software suppliers. It was already said that there are 4 main use cases. Specification of an information architecture, for instance, as a strategic guide for system planning and evolution, when you want to change, for instance, to renew your implementation platform. This is also used for a specification of a database. It is the starting point for the definition of what information you need. In the evolution of the technology, it's also used for the specification of an interface, and now we are focusing on NeTEx and SIRI. And these two have defined particular exchange formats and even a protocol for the exchange and publication of information that has been modeled in Transmodel. As a reference, Transmodel is also very useful. This has been presented by Nick Knowles in the mapping of different transport data specification, as it is a standard and stable reference. In the introduction to this webinar, Fabrizio has already shown you the list of different data domains which are part of the Transmodel framework. In fact, they correspond to the different documents where you will find the data models and the textual description and all these data dictionaries. And in the last, in the next minutes, I would like to give you an overview of what the common concepts domain is, what the public transport network means exactly, what we mean by timing information or vehicle scheduling, which are the key concepts, and so on. In this picture, you see the corresponding parts, part 1 here to 8, of the and the titles of the documents, the corresponding documents, but also the link with the corresponding implementation standards. So, for instance, part 4 is implemented. Parts of the data modeled by part 4 is used in the by SIRI. Of parts of part 5, fare management, in particular, the tariff model is used within NeTEx part 3. And there is a new an extension, part 10 of Transmodel, which is planned to be republished. It has been already published in 2019, last year, concerning the alternative modes. So let's go to the details, more details. What are the common concepts? Common concepts comprise the models used in all other parts. So it will never be used as a standalone part. It provides you information about versions of data, validity conditions, and responsibility upon data. Second domain is is called generic framework. Here you have the models that present you, let's say, design patterns representing what are the zones, the points, the link sequences, the layers of static information or spatial information, projections, so correspondence between the layers, places, but also groupings of data, group of points, group of links, and so on, accessibility features, and finally, other type of components are reused in other parts, so transport modes, calendars, addresses, topographic places, generic equipment and facilities, vehicle types and trains, and transport organization, and so on. So this is the domain of the common concepts, which is used in part 2. In what is part 2? Part 2 is entitled Public Transport Network. Many people think it's the infrastructure. Not exactly. There are some concepts concerning the infrastructure, so road links and so on, or yes. But in fact, what we are modeling, it's the service infrastructure. So it's the spatial representation of how the vehicles work. So the key concepts is the journey pattern, which is defined as an ordered list of scheduled stop points and timing points on one single route. And a route is what I just mentioned, is a schematic vehicle path through the network. We model their connections, network restrictions such as overtaking possibility, impossible maneuvers, meeting restrictions. This is implemented as NeTEx Part 1. and Transmodel Part 2, but together with Part 1, which is common concepts. As regards the timing information, you had already some information about this in Christoph's part, but here you see really the key concepts that represent this timing information. So one of the concepts is the vehicle journey, which is defined as the planned movement of a public transport vehicle on a day type. So this is really the planned movement, the planned work of vehicles. Here we present different types of journeys, service journeys, dead runs, but also coupled journeys and journey parts, which is, of course, necessary to represent the work of in the rail world. We define different types of run times and wait times, different types of times in general. And a timetable is in fact an aggregation. It's represented in the so-called timetable frame and is aggregated data. This part also includes operational vehicle schedules, including blocks, vehicle services, and this is all aggregated in a vehicle schedule frame. This also includes flexible services and is implemented as NeTEx Part 2. As regards operations monitoring and control, we are here in the so-called real-time world. But the real-time in our world means what is happening on a particular operating day. So the other concept, tactical planning, is designing and building reference schedules, which may be then adapted in a further phase. We start from, for instance, vehicle journeys, so planned journeys for day types, and we go to dated vehicle journeys, which are on an actual day, operating day. This part models detection, monitoring, but also different types of control actions. And these control actions have the particularity that they modify, amend the production plan, which is the reference version of all production activities. This part models also events and messages to represent the public transport situation, so incidents or deviations affecting the planned operation, public transport operation, and also monitored facilities which have may have different states of availability. So you recognize easily that this is implemented by SIRI, so the data format to exchange parts of the information that is modeled here, real-time timetables, connections, but also situation exchange and facility monitoring is implemented by SIRI. Now a very big part, fare management. Many people are interested by this part, and I think it will need some particular webinar to explain the exact contents of it. Let's have some words about what's inside. Actually, Transmodel relies on the definition of access rights to transport services. So access rights are defined through elements of a fare system, so rules to access public transport, and the relevant parameters, quantitative, so how many, what portion of this service you want to use, when is it valid, and how to use these access rights. These rules are, as said, described through a whole number of parameters. Access rights can be combined. This is mainly one important feature, may be combined, as they can be combined originating from different fare structures. So you can define an access right, for instance, a bus trip together with access to a parking or to a swimming pool. Fare products are combinations of these access rights. They are materialized through travel documents, and this is offered to the public. They are grouped to be offered as sales offer packages distributed through different distribution channels. And once a customer purchases or intends to purchase a sales offer package, this sales package becomes a sales purchase package. And what happens afterwards as regards the process? Different processes are also modeled, so the data needed by the after-sales processes, so the controls which are applied to the access rights present to the fare media, on the fare media, in order to validate the use of access rights to identify an offense and to be reported on blacklists. As regards the prices, price elements are defined to be able to compute the actual price of the purchased fare products and sales packages. Now, we are still in the Transmodel framework. What about the passenger information? Of course, passenger information relies on part 2, because you may be interested to have the information about the network, the network topology, and to have this information on a screen or on any other media. You may be interested by the static timetables or even or the real time, so actual timetables. Therefore, the passenger information domain uses many concepts from other domains, but one concept which is particular to this domain is the trip, namely the trip model, where the main concept is the trip pattern, defined as a movement of a passenger or another person, for instance, driver. We say an entity, from an origin to a destination place, done for a specific travel reason. And such a trip pattern may consist of one or more consecutive trips. You see it on this slide. You can have public transport trips, but also non-public transport trips on a private vehicle or like a bicycle. And these trips are split into legs. So also concepts underpinning trip planning requests and responses are modeled as used by the request. I want to go from A to B. I want to know the arrivals, departures, at stop at one particular stop. All this is represented as a model and is implemented, used in the open API for distributed journey planning, known as the OJP specification. One part which is much smaller but and not really concerned in NeTEx and SIRI for the time being at least, is the driver management part, where we represent different driver scheduling related concepts like duties and their components, duty parts, stretches, spells, breaks, and so on. Driver rosters, the resource plan, and also the link between driver duties and the blocks, so the vehicle work. Here we have also driver control actions, similarly to what is represented to vehicle control actions in part 4, like change of driver, driver cancellation, and also another different part of this driver management is represented in the driver accounting part, where the records of driver activity are represented and modeled. Fabrizio Arneodo is the leader of the OPRA, if you remember, OPRA work item, which deals with raw data that is registered to be able to calculate different types of indicators. This, the part 8 of Transmodel describes how to structure this raw data, which either refers to the planning stages or to the daily actual production, and which is registered for different purposes. We have chosen this approach in order to develop a generic structure, a sort of design pattern, which shall be used to represent the changes of state of objects, and to avoid describing multiple data structure for each indicator, for each use case. So in the next months, the OPRA work item intends to produce implementation part concerning this particular topic. I won't show you this Transmodel video. It would, in fact, you can see the summary of what I've presented now on this video on our Transmodel site. So you have here the link. It lasts 3 minutes. Some words about the timescale of data domains. Transmodel describes data for planning purposes. So you see on this slide, on the picture here on the right, the planning stage, the operations stage, so what happens during one operational day, and historical stage of data, registered data. So we can say that, for instance, the domain of fare management has, but many domains have a component, so a part of data which is concerned by the planning stage, and a part of data they model on concerning the operational stage and the registration, the historical stage. This is mainly to tell you that in the document concerning the fare management, you will see information concerning the planning stage. This is modeled, so the static data. This is then implemented by NeTEx, but you will have information concerning some real-time operations. This is sales or the access right control and validation. And this is modeled in Transmodel, but not implemented by NeTEx. As regards the transport modes, I already said we have modes and variants of modes, which is called submodes. We have given to public transport the following definition. You see it on the bottom, at the bottom of this slide. This is public transport corresponds to modes of operation advertised and available for use by general public. This means that what is in Transmodel corresponds to the conventional mode of operation, scheduled operation or flexible operation, but also to the alternative mode of operation, vehicle pooling, vehicle sharing, and rental, because these are publicly advertised. Whereas the personal mode of operation, this means the use of your personal car and your personal bicycle, nobody knows that you will drive somewhere. This is not our topic. As regards the methodology, already Nick mentioned this, you have seen this slide previously. Transmodel is on this first conceptual level, which is implementation independent. And you may have multiple physical models depending on the implementation type you want to have. And NeTEx SIRI has chosen the XML implementation schema. Therefore, the physical models are also built for this purpose. Here, in short, the characteristic Transmodel is modular, not only divided into parts, but the Transmodel conceptual model is split into packages. You see here these boxes, which, for instance, for the common concepts represent versions, validity, responsibility, and so on. These are the different packages. So information which in a way belongs together. And you will see the corresponding packages in the physical model for NeTEx. And you will see the corresponding files in the schema, in the NeTEx schema. This has a big value if you want to extract for a profile, for a specific use case, parts of the model. You can start with the conceptual model. Of course, you have to look which packages belong together because there is a dependency between these packages. And then you can extract it in the physical and in the schema to work with it. For those who have never seen how a conceptual model may look like, I have put this this picture. So Transmodel is modeled using the unified modeling language. This language shows you one diagrams like this, where the data concepts are in boxes, and data concepts have properties. So, for instance, here the topographic place has a center, an ID, a name, and a qualifier, and so on inside these boxes, and the data concepts are related through these lines, which represent specific types of relationships. Here I wanted to represent the stop place with particular keys, a number of keys for a particular primary vehicle mode, which is in blue on this slide. As already mentioned before, the exchange format or the publication format has been chosen to use XML. So such a diagram is translated, and the translation rules are described in our documentation, is represented, for instance, through such an XML document. To finalize my presentation, Transmodel has started a long time ago in the Drive 1 program, start of the 90s. And one maybe important fact was the Titan project, where two big pilot sites have been implemented, and as already mentioned by Christophe, the Lyon site is still in operation, has been extended. The second important date was 2006, when Transmodel version 5 has been published first as an European norm. Each European norm, EN, is revised every 5 years. So the decision is taken to update it, to remove it, or to leave it as is. It has been decided to renew Transmodel, and between 2016 and 2019, Transmodel version 6 has been generated. You see, the work was long. It was long to bring together all the funding to do that. And now we have to take another decision. Shall we republish all these parts? In 2021, this decision will concern parts 1, 2, 3. At the same time, we have published the extension to the alternative modes as a technical specification last year, TS 17413, which will be republished as Transmodel Part 10 in coherence with NeTEx Part 5. The question is, where is all this implemented? There are several implementations around Europe. Not all are controlled by us, so it's very difficult to say this is exactly a Transmodel implementation. As regards the Titan was the Titan project has given us a good example of a big data repository. The data exchange formats are implementations controlled by NeTEx and SIRI, and you see here the links to the different sites where you will see some examples and some information. Now, about the Transmodel implementations, we have tried to give you some details about the major implementation on our Transmodel Sense site. And you see there a map. Clicking on the different countries, you will see examples of such implementations. And to finalize my presentation, I go back to this Transmodel ecosystem and stress the importance it has with the delegated regulation for multimodal travel information services, where different data categories, a list of data categories is mentioned to publish these data categories using NeTEx or SIRI, and based on the underlying conceptual reference model Transmodel explicitly mentioned. And I would like to add that the data categories have not been defined in these regulations, but if you go to Transmodel, you will find many of the definitions. And this is also a big importance of Transmodel, which gives you information what to implement on the national access points. Thank you.
Thank you very much, Kasia, for this detailed and clear presentation around transmodel elements. And now with all this in mind, I suggest you to go to the last presentation for today with Ulf Biersing, who will present you some concrete implementation and case studies of Transmodel, SIRI, and NeTEx. So please, Ulf.
Yes, can you see in this presentation?
Yes, we can see.
Yes, we see.
Very good. Yeah, so my name is Ulf Biersing, and I'm going to try to show you some implementations and case studies concerning Transmodel. And I worked for 30 years, almost the same time as Transmodel has existed. And I worked a lot with Transmodel over the years. But I've also seen what is happening over time. And we're coming from a world when we had implementations where you had typically one system. You had the bus system and you wanted to present information around that for passengers. And okay, so you had one technical system and you implemented the presentation solution. But over time, the scope was extended and you had to add information concerning other modes of transport as well. And now maybe we got some type of problems here, because first of all, the definitions we used for the bus system maybe didn't interact, and typically we may have to involve multiple suppliers. So we needed standards, and we needed standards how to communicate and convey messages. And it was not only the scope that was extended over time, it was also, as we've seen now, we have e-scooters added and other type of personal transportation. And there's an ever increasing expectation of integration of information from different sources here. And this is where it's so very useful with Transmodel, where we no longer have one supplier, but we have many suppliers and we have many organizations involved and multiple modes to consider. And the thing is, we're not only interested in presenting information to the passenger, we need to be able to create quality information and taking into consideration all these aspects of so many suppliers, so many involved organizations. And I think this will continue. We also see that the division of responsibility is very different in different parts of Europe. So together with Hector Coracina, which I saw was previously in this meeting, I was in the European Bus System of the Future project around a decade ago. And one important thing was we discussed how do you build these regional information systems that really give the complete picture. And historically, the now line as of a decade ago, typically you started, okay, we want to integrate information in this region. Let's make an engineering project of this and add stuff as we go. And this is possible. You can do this, but it takes time. And then you get to do specific developments to describe this to get your results. The path we tried to push in the European Bus System of the Future was to use standards and use specifications instead, and having specifications that actually cover the needs, it's much faster to come to deployment. And then you might be able to reuse previous use cases. You use the same technical platform for different purposes. So going this path, which today is quite, everyone thinks this way, it saves cost, it saves time, and it makes possible new solutions. So this was things we did in the European Bus System of the Future. And this also actually pushed the development of extensions like NeTEx to provide the planned information in addition to the real time, which we already had at that time in SIRI. So, oops, strange. I would just like to remind here, excuse me, it's sorry, there was a hidden slide here. So after the European Bus System of the Future, we had the 3 IBS project, and then it was followed up by the European Bus System of the Future project too. And there participated in a field test at Transport for London. And for this test, we wanted to test, is it possible to have many providers working together in a solution and getting consistent results? And there was actually companies from Sweden, from France, from Switzerland, from Germany, working together and testing this in the environmental transport for London. So we developed profiles, NeTEx and SIRI profiles in this project. And just to remind you from Nick and Christoph's previous presentations, a profile focuses on what is needed in a specific context. As many of you have pointed out, these standards are huge. They might be 1,000 pages. We need to have a profile that is fit for the job and can focus on what is needed, but using the standard, and also clarifying and filling the small gaps that are left as optional or voluntary in the standards. So again, with a slightly changed picture from Nick this morning, we have the EBSF NeTEx profile as an example. And again, this is just a reduction of the NeTEx full schema. And in it, we defined how should we expose the network information, the stops, the distances between stops, and so on. And the timetables, at what time will the bus go past the different stops. And also the planning of how do we operate the vehicles, which journeys will they perform and at what times, and how do they go to the depot and back and so on. So all of this we included in the profile, the EBSF2 NeTEx profile. Sorry, I have some more hidden slides here. I don't understand this. I need to unhide them. Yeah, there we go. So, sorry about that. So we have this profile. We defined what parts of the complete NeTEx are we to use and with what definitions and so on. So the first task was getting the data from Transport for London. They had all this information available, but in a bespoke format. And this was the work of one provider to convert this information instead of having all 5 parties involved on this. So one party converted this information into NeTEx. And then all the EVMS providers involved in this project could use the same data that we had agreed on, which was NeTEx with this specific profile. And in this way, The AVMS systems got information about the networks, the timetables, and the vehicle schedules. So they knew what each bus was going to do during the day. Yes. So in each of these AVMS systems, the provider individually followed the fleet they were working with. And in this example, they had one single bus they were working with, but they had the full extent of data for the operator. And in return, they sent the real-time movements of these vehicles using an event-based SIRI profile. So we knew when a bus departed from a stop, when it arrived at the stop, when it signed on, and so on. And all of this data was sent to the multi-VMS coordinator, and it could in turn provide harmonized, consistent information. So in this way, we use Transmodel to get data from many different technical providers, and yet we were able to work in a way that we got harmonized, consistent information out from the system. So there are many levels you can work on. I just showed you within an organization. I will also now show you how you can work within a region. This is an example from Sweden, a region in Sweden, where we highlight the possibility to use Transmodel to have a very good separation of concern, and at the same time, very good integration of data. So in this case, it's the public transport authority's responsibility to define the stops, their names, the references, and also where they are located. However, the public transport operators in some cases have in their contracts that they should provide updates if they find problems with the locations. So in this case, there's a technical format where they can provide new coordinates for the stops, for the ones that they're operating at. And this information, the stop information, and a lot of other basic information that you want to keep the same, is provided to the different public transport operators. So they all have the same set of stops to work with, the same references, but then they're responsible themselves to produce the timetables and to produce the vehicle schedules, the driver scheduling, as we talked about earlier also. So all of these are their responsibility, so they can provide the correct operation as contracted by the authority. So they use a Transmodel-based format to provide the timetable information. They do not, in all cases, need to provide the details of the vehicle schedules, the planning of the blocks and so on, nor are they required to provide their driver scheduling. But having these timetables and all the stop data, the authority can then build a coherent data set that fits together, and then it in return provides the combined data set stops, timetables, and interchanges to all public transport operators and all different technical systems. In this region, there's a mix of authority-owned AVMS systems and public transport operator-owned AVMS systems. Also, advanced interchange possibilities, connection protections are sorted for. And the problem is, the devil is in the detail when it comes to this, because you could have buses that are to wait for trains, for instance, and the timetable for the bus is sent in at a certain time, but after that point in time, maybe the timetable for the train changes a few minutes because of the allocation of tracks are changed. And using Transmodel, it's possible to define very good rule-based connection protection. And that means that the bus do not need necessarily to change their schedule just because another line or train or whatever has changed their timetable slightly. They can still have these interchanges work. And this division of responsibility and separation of concern is strongly helped by the way Transmodel supports the division of stable identifiers and version handling in detail. So from these different AVMS systems, we get information back of the events that happen. They depart from stops, they come to stops. There are also different technical systems using Transmodel-based interfaces where they can send the control actions themselves, saying, okay, we cancel all traffic on this part of the line because we have some malfunction, or we add new journeys, or we go another way, or we change the timing, and so on and so on. And all of these details are collected centrally and then applied, meaning that we have this coherent static dynamic data available for the regional travel planner and also for regional dynamic passenger information and so on. Going further, having this coherent static and dynamic data, we also use this to send to the national access point. And having multiple regions in parallel, the national access point can aggregate and provide static and dynamic data on NeTEx and also on Ttfss and Ttfss RT. Looking on the European level, we've been into this before. It's about providing union-wide multimodal travel information. And as mentioned, the delegated regulation 1926 is a lot about this. How can we assure that we have this type of information? We want all, and what is stated is that there must be national access points in each country, or a couple of countries working together. And it's actually not stated that these need to be databases or anything like that. It can just be a point of access, and it can be decentralized if you wish. But in many cases, you will have a physical point where you assemble data. And maybe you change format in the national access point from some language, some country-specific standards and profiles to a uniform standard. So, as Kassa mentioned, it is mentioned that you should use NeTEx based on Transmodel or something that is data-oriented and equivalent for the static data. And also in the case that you provide dynamic data in the national access point, you should use SIRI, which is also based on Transmodel. Concerning the NeTEx supply, there's also mentioned that there is to be a European passenger information profile developed. And this is with the intention of making it easier to have data that is easily exchangeable between countries. And this is something we worked a lot with in the DATA4PT project. So the European passenger information profile is a common minimum profile at the national access point level. You can get it from your local standardization, your country's standardization organization. In this case, this is the Swedish SIS. Right, so I would like also to talk about the Transmodel implementation in Norway, which is very interesting. Here you have a national access point at Entur in Norway, where they have an application where you can update the coordinates and the names for the stops, and this is used widely by the different regions. And in this way, we have a common stop database for all of Norway. And this is then used by all the regions, the authorities in the different regions, and it's also for all the operators to be used. And again, similar to Sweden, but what I showed for the region is here the same on the national level, that the regions and the operators must provide the timetable information using NeTEx and using a specific Nordic profile to the national access point. So there is a published on the net, which you can find if you look, a Nordic NeTEx profile that in detail give a description of how you should provide information about timetables, interchanges, and so on. And there's also a profile for SIRI, how you provide real-time information. In this case, if you look on the SIRI ET, it is not the event-based kind. It's more you always send the complete information for a specific trip, sorry, a specific journey if it changes. So you need to be aware that you may have to send a lot of information, but then the same information as you send into the national access point can also be subscribed on from different parties. So you then, so it's possible to get as open data, both the static data as NeTEx and the real-time as the SIRI that is provided from the different parties. And this is used for the National Travel Planner, but it's also used for different purposes. And you can, again, if you have a regional travel planner, you can get information for your adjoining regions using this data. I got a question previously here concerning driver scheduling and why do you need that? Why do you need to exchange that? And to go back to the example from Stockholm, you may have different applications. You may have one application that optimizes the driver scheduling. You want to be very efficient because the driver is very high cost. At the same time, if you have problems in real time, it's very important to know to what limit can you change the timing of the vehicles, because the driver may have been working too many hours so that you cannot actually ask him to work any longer. And all of these aspects means that it is important for the AVMS system maybe to know details about the driver scheduling, to know if it's possible to extend the journey or doing any other control action. That said, we don't have everything of this in SIRI, and we have partial support in NeTEx, but in Transmodel we have a lot of details about this, and we may continue developing this if there's a push for that. So using Transmodel, it's much easier to go from the concept of one supplier, one organization, one mode to multiple suppliers, multiple organizations, and multiple modes, and having this working together with quality. Okay. And I would just like to end with pointing out that we have a DATA4PT website and a wiki, and you can see more. We've provided some support if you want to produce the EPIP data, some examples, and actually an adapted XML schema definition that makes it easier to produce these files. Thank you.
Thank you very much, Ulf. for this complete description of implementation examples. This is very useful to illustrate and give some highlight on some practical case studies. We can still take some questions, if any. I see on the chat some discussions. Is there any additional questions from the audience regarding this presentation, or more in general what has been discussed today? Just maybe a comment regarding the questions from Eve Amsler about availability of and cost of standards. Just to confirm that this is an open topic. I mean, the availability and access to formal EU standards, which has been shared with the national standardization bodies and European Commission. So we expect here to have in coming month maybe some good news on this part. At least some national profile and all technical artifacts are made available on different platforms and the GitHubs. So that's already some very useful elements you can use and access for free. And the formal standards, as any EU standards, is right now following the formal rules through the national standardization bodies to access the formal documents. Okay, if there is no more question, I think we can close the meeting. So I will just share some conclusion, and I think also just before closing, we'll try to take a picture of all attendees. So we will ask you at the end if you wish to turn on your camera just to have a souvenir and share on social media. But yes, just to conclude, I hope you enjoyed this journey this morning, and that we offered you some useful information about the Transmodel ecosystem. Of course, all presentations and record of this session will be made available on DATA4PT website, so we'll be informed in due time about it. And of course, feel free to share this material with your own community. This was the first training offered by Data4PT, and this will be the first one of a series of trainings, which will come soon in coming months. So you will have all opportunity to join other webinars, and we will focus on some functional scope. For example, we are already working now on a dedicated training on real-time information and SIRI-related implementation. So this will be definitely the next webinar, which will be organized quite soon. Also, as Anastasia mentioned in introduction, all Data4PT experts are available to answer any questions and provide technical support, including training for the member states. So feel free to contact us. You can use the Data4PT website here again if you have any needs, or if you want to share any return on experience. It's very important, as you understood from this today's presentation, to share and to exchange about these good practices around Transmodel implementation. So to conclude, I would just like to thank the European Commission for their support in this project, UITP for the organization of the webinar, all the speakers, Anastasia, Kasia, Tito, Fabrizio, Christophe, Nick, and Ulf for the great presentation they are delivered today, and of course all of you participants for joining this webinar. So if you can just, yes, turn on your camera, I will do it also, just to say goodbye and to take to take a group picture, to post it on social media. So yes, if you wish, if you can, just turn on your camera. And we will just try to take some picture. Okay. Thank you all. Enjoy the rest of the day. And we highly hope to meet you soon, remotely during this training session and by chance through physical meeting in the coming month. Thank you all.
Thank you.
Goodbye.
Bye.